My name is Alkin, and today we're going to talk about AI-powered alert analysis with my colleague Boris. Who we are? My name is Alkin. Once again, I'm the director of services at Altinity. I'm an open source database evangelist, also known in the some other open source database world. I am a co-author of two open source database books, and MySQL Rockstar and MySQL Oracle Ace Pro. And Boris is a support engineer at Altinity, and he's my colleague. We work together day-to-day operations. He's one of the known ClickHouse experts in the ecosystem. So let's get going on this talk today. One more thing before I start, I really wanted to be part of the OSACon for a long time, and I'm very happy to be here. I don't want to forget about that, and appreciate everyone's efforts putting this conference together. So, agenda for today: using AI for alert analysis, preparing requirements and the data, what data to use, and then we're going to get some setting up the environment, getting ready for this AI tool that will get us the demo for today. So that's going to be two parts, and I will be kind of giving you the preparation parts and what we need for it. We will be skipping all the AI stuff, so I'm sure that everyone had enough of AI talks today, or it's what seems to be the trend nowadays. But we want to kind of showcase what can be useful with a given AI tools and implementations and using open source databases and tools. So I will start with the end, the goal in the beginning. So this is the reverse order. For the alerts is the subject over here. We have the categorization of alerts based on the urgency and the importance, determine which alerts are going to be required immediate action. So these parts are already done by the known tools. You get alerts, there's a monitoring system, thresholds are set up, and then you have something to fire off and then receive that and deliver it to the engineers who will be actioning them. This part is pretty much done. Whether it's a monitoring system that gets it fired over Opsgenie, PagerDuty, whatever other tool that you might have, and then you receive those and ingest into certain system that will be triggering. But what's important over here? How do we define, categorize, and basically get something off of these alerts? And this number 4 over here in this little picture is implement a system that can do something that seems to be an utopia right now. It may not be available, but it is doable in the face of the AI world. So basically, like I'll say it. What crosses my mind: change the threshold, and if this alert is going for this node or database or the cluster for a prolonged period of time. So that's the plan. Why are we doing this? The alert fatigue problem is a known problem in a large system. We are at Altinity managing hundreds of clusters, hundreds of nodes, thousands of nodes, which are firing a lot of alerts. This high volume of alerts is difficult to handle, and there's a risk of missing the critical alerts, and they get unnoticed. And then the triage process is one that the alerts number reaches to thousands, tens of thousands, is difficult, and that will be inefficient manual triage process. So that also falls into our engineers on the front line, and sometimes missing few alerts can cause a chain reaction of other problems that degraded service or a downtime. And we need smarter alerts. How do we actually tune the alert? How do we disable some of the alerts, or change, make modifications to those, and then basically integrate into an automation tools? So that's the plan over here to tackle. This is something done even pre-AI, with the tools that we have. The KPIs. We set up dashboards using Grafana, Prometheus, and ClickHouse databases. That is doable. And then you can also generate SQLs to run those using AI. But I mean, it's not something, it didn't exist, but didn't give us what we needed using the AI, especially the agentic AI models. So going back again, where do we keep this data? It's a ClickHouse. So ClickHouse is very suitable for this type of data because it's a performant database for the large data sets, and it's a comprehensive system. The ecosystem is growing, and it's actually really stable, and it's scalable architecture. If you have big data that like that translates into an observability data stack, the ClickHouse is really suitable for that. And it has efficient storage model, which we call it a tiered storage. You can actually keep keep the data into different storage layers to save costs. So that's the database data store that we will be presenting today. And the pipeline, where, as I mentioned, the pipeline basically, and we will go what's under the hood after this. But the pipeline basically is to get the alerts, store it in the database. How you do that is, for us, is slightly different because we use Atlassian Suite, and then that has an API and SDK. We extract that data and then store it in the ClickHouse database. And that might be different for other people, scripting or using the APIs and calling it, and then basically get that data ingested into the data. Then the story starts, whether how do you present this data into getting into more actionable, as in the first goal part of this talk. So we will go into the details of how we put the pieces together to generate something meaningful out of the way. And don't worry about remembering what's in here. All the slides, recording, the GitHub repo, everything else will be shared at the end of the talk. So with that said, I will leave the floor for Boris to show up the what's under the hood for this demonstration.
Okay, hello guys. So why use LLMs for data analytics? We could use different tools for BI like Grafana, Tableau, Power BI, and many do that. However, the question how to do it better. So what the problems? So rigid models. So the typical work process is to build a dashboard and try, see, and get some results on that side. And iteration is quite slow. So from the idea of the question to the result, it could take much time. Or you should be very proficient in SQL queries and write SQL queries very quickly. Okay, it's possible. Nowadays, you could use LLMs to write SQL queries and do some cut and paste back and forth to get the data from the database. And that is not a good solution. We want to present something better. So how I could imagine a new BI architecture? So the typical BI user goes to the ChatGPT, Claude, any other chat UI, and work in the friendly environment, do some chatting with a knowledge base on some sort. That is a common habit, and many people now use that in everyday works. And our goal to provide access to ClickHouse database. So for that, we invented, not we, but cloud invented MCP protocol, where the server is some intermediate entity that can do something by client calls. The client now is the LLM itself. So a large model could execute a tool to MCP server, and MCP server could do something. In our case, our MCP server could pass the SQL query to the ClickHouse, return data back to the model, and model return the responses back to the user asking the question. So it's a general overview how it works. User ask a question, send to the model create a tool call to MCP server, and is SQL created by the LLM, pass it to the ClickHouse, and the data comes back. There are different MCP servers on the planet, and there are several for ClickHouse. But here in Altinity, we decided to create our own MCP server. Why? First of all, of course, it's designed for ClickHouse. We work with ClickHouse and we work for ClickHouse. So it's a special MCP server for accessing ClickHouse data, databases, table, all the stuff. We decided to use Golang. So Golang is more performant, easy to install, no Python dependency hell when you want to install it. So it's a robust professional instrument to building software. Our MCP server supports all different access kinds. So the old one, like stdio for running locally, the first attempt of MCP to run over the network, SSE, and the modern standard HTTP streaming. For now, we have two different type of tools. So one is the static execute query. So the idea is that LLM create a code, SQL code. LLM could create quite complicated code and send it to ClickHouse. ClickHouse execute query, do some aggregation, joins, all the stuff, and return a short result to the model context window. Also, we proposed a dynamic tool creation. So it's quite unique feature when you could create a parameterized view inside ClickHouse, and result of the parameterized view will be presented as a tool result to the model. So you could create quite complicated scenarios like search, fetch, and so on. All depend on the imagination. Talking about authorization, you have several different options. So first of all, of course, we support password authorization. The user password could be passed from the model to the MCP server to authorize over ClickHouse server. But it's really not a good idea to provide a password to the models. So we provide encrypted token, GVE. So with inside such token, you could pass all needed to connect to ClickHouse server. Not only login and password, but also host, port, secure access, and so on. So this is you could consider such token as encrypted password. So it's still vulnerable to leak, but not so great. So in such big effort like a password. Also, our GV token have an expiration time, so you could create a token very easily for several hours, for example. Of course, the best way is to use OAuth. We still not support OAuth because ClickHouse do the same. And we expected when ClickHouse, the community version of ClickHouse, the open source version of ClickHouse, start supporting OAuth, we immediately supported too. As I know now, the process is going, and Altinity Antalya build already have it, and Altinity stable version will have it from 25.8. The same Altinity MCP server. And of course, we are open source. You could go to GitHub and download the source code, the Docker version, all the stuff. Okay, How to connect to LLM? When installing MCP server, you and creating a token, you efficiently create URLs. So it's host name, HTTPS, and a token in the middle, and HTTP at the end. So it's HTTP streaming protocol and the URL for using that. Next, you could paste such URL to the administrative user interface or some config text files to any modern chat application. All supported now. So it's Cloud, ChatGPT, Cloud version like Cloud Code, Codex, Gemini, and many alternative chat UIs like Manus, LibreChat, a lot of them. If it talking about cloud, then so this is the user interface. So you should create a custom connector. So in cloud, there are some standard connector well known like Google Drive, Notion, GitHub, and so on, and ability to create a custom connector. In our case, we create custom connector, give name, paste token, and won't provide any additional authorization, and press add. And now you have MCP server connected to the cloud, and you could use it. So, but which data to explore? Which data to explore? So, because the whole idea is for our customers. So here in Altinity, we create the solution for our customers. We have 300 companies in Altinity Cloud, and we need to provide a valuable solution to explore data by modern LLM tools. But first of all, we should create some own solution and use it in our real life. So we decide to use our alert database to explore data through LLMs. And the good database, not too big, not too small. Many people understand the problem and could try and check and so on. So we love it. So we have a pipeline to get data from Atlassian and push to the ClickHouse. Creating a valuable table schema is essential because source data often came in some tricky thing. So it could be a map, JSONs not structured well enough in different formats and so on. Here is our case. We have different types of environments for clients, the old one, the new one, and all the problems the average user have. So first of all, we need to normalize the data, create a valuable schema, so any LLMs, the same as any human, could explore it with too much questions. So here's our schema, and there are very important columns like cluster and environment. So here in Altinity, we provide the environment as a Kubernetes environment and several clusters inside them. And that is important for our alerting system together with severity, alert type, and different timestamp. So here's our schema, and we'll explore it. After all, you should create agent, because starting chat each time from a white list and explaining all the knowledge you have, it's very impractical. You have to create some standard prompt to explain all you know about the task, about the data, about your requirements, about your habits, all you need. You could imagine it like instruction for the human analyst that come to your company and you do some onboarding for them. and explaining how the company works and which the corporate standards and so on. Here is the agent, agent and agent prompts. For different instruments, agent created differently. So if you decide to use Python to write an agent, you know what to do. However, if you decide to use ChatGPT or Cloud, you have to use a special instrument inside that user interface. In Cloud, it's called projects. So you could create an entity named project, provide prompt, and go to the project and start exploring data inside the project. The prompt will be applied to each chat you started inside the project. For the ChatGPT, the same feature called GPT. So you create a separate GPT and provide a prompt and all other stuff. You should understand that all the prompts, all the data, all the user typed, all the MCP server responded, place it into context window, into model context window, and earn and spend your tokens. The context window is not too big. For it's like 200,000 tokens only. And we should not overload agent prompt with too many details and too many data. It's related to the basic prompt. You couldn't create a huge book of instruction for the model. So it should be short and precise. And the same for data. Recently, Cloud introduced new feature skills. So it's not a static single prompt for the agent, but a set of different prompts that Cloud could search and load only when needed. That is very important to use it for complicated situation, and we explore it later. So here's a screenshot from the server project instruction. It's my prompt for alert analyst. So it's a typical prompting technologies. You are alert analyst, specialized assistant who helps find problems in ClickHouse. And some instructions and requirements for the agent to explore data in the right way. So not some random, but the way I need to do. That is the instruction. Actually, the prompt is much bigger, not much, like 3 times. And you could see the full prompt in GitHub repo I created especially for this talk. Also, you could provide recommended tools. So here is the one. So you explicitly say to the model which tools should be used. And after all, you could ask your question. So you go to the project, type a question. Here is the MCP server already configured and enabled, and the model could use that MCP server during the research. I will try to show you a real demo with the cloud with exactly that question. Okay, so here's the real queries executed by the model to the ClickHouse server, and it shows data overview. Okay, so we got a result from the model and with key finding and the value, the text you could exactly use for the to get inside. And the model also present from button text for us. And also it recommends to do visualization by some type of dashboarding. I have a second demo and have prepared in GitHub repo. I want to discuss a little bit about dashboarding. So text is great, but sometimes we still need visualize the data. And a model could create artifact. So model is quite good in writing code. So in this case, it's HTML or JavaScript code. And it do it for you, but sometimes the design and colors will be completely random, as all is going from the model. And we need to stabilize the design and colors. That is exactly cloud skills help us. So it's additional style of prompting we could use to create a model, a dashboard. And we have two different options. We could embed data directly to HTML, but data will came through the context window. It's not so good. And we could write a code that will load data directly from the ClickHouse server through the Alkin TMCP. So that is two very useful and important approaches. Here's an example of alert of the dashboard. So a dashboard created by a model with some key insights, statistics, and graphs. That's another.